Hi team! Thanks so much for joining for your math learning. It's finally time to discuss this problem. A point P, we have the square QRST, and we choose a point P randomly, and we want to know the angle formed by two corners on a side and this random point. Is it acute or not? Okay, so you might start out by creating a little diagram here. All right, oops, my little diagram looks like this. All right, so there's QRTS or QRST, whatever, it doesn't matter. Okay, and then I'm gonna just draw my angle. So my angle would be like coming from Q going to P and then going back to R. Boop, there's my angle. And I am interested in when is that acute? Okay, so to know if that's acute or not, we really just need to think about where P is. If P is like way out there, it's clearly acute, right? If I pull P in here, it's clearly obtuse. Wouldn't it be nice if I had a beautiful Desmos visualization for you about this? Okay, so let's take a look at this here. All right, here's point P. When I have point P out here, clearly acute. When I pull it in close, clearly obtuse. But we want more than just proof by just look at it or just guess, okay? When I asked an engineer this problem, he said I would program a computer to look at millions of points and then compute the average probability. And I said, well, I think I could probably still do that faster. And he said, well, I don't want to use my processing time. I want to use the computer's processing time. I said, yeah, sure, but like, it's a fun problem if you don't. Oh, wait, if I put it up there, it's acute. And it's like acute up there, but then it becomes obtuse in here. Where is the borderline? Well, the borderline happens to be right in between. Oh, I keep on thinking it's over here. Right in between the acute and obtuse areas, and we need this circle property, okay? Imagine AB is the diameter of a circle. Any point on that circle will create a triangle ABC that will be right angled at C. This is a circle property and it shows up here. Let me show you this circle property inside our beautiful Desmos visualization. Let me turn on our circle. Boop, we're just gonna make that equal to for now. Equals that, okay. So now, if I pull point P so that it's exactly on that circle, or roughly exactly on that circle, that's when it's going to be right angled. Notice it still looks right angled over there. It's still right angled as I move it around down here. It's right angled everywhere, actually, along that point. Out here it's acute, in there it's obtuse. So that actually allows us to use that principle where any point along there, it's exactly 90 degrees. Inside that, it's obtuse. Outside that, it's acute. Okay? So let's turn this into an inequality. I think it goes this direction. There we go. So now, what we're interested in is when is point P in this red area? Like, what's the probability that if I just punk point P down, it falls in the red area and not the green area? Okay, that's how we'll find the probability, is the areas of the two parts of this square. Okay, now we've got a nice Sangaku problem. All right, this is a nice geometry problem. So I'm just going to tidy up my diagram here. And I'm not even going to consider like a point P. I'm just going to be considering that circle, right? So just get a little bit into the corners. Into the corners. There we go. Oh, it took a little bite out, but who cares? Not you, right? Not you. You don't care. Okay, and so now I'm going to draw this circle, half circle. Ugh, ew. Why did it do that? Beautiful half circle, which apparently I have to finish. Boop, there. Okay, there's my beautiful half circle. That's going to be good enough for now, all right? And I'm going to put on there, I'm going to have a radius to calculate that thing's area, so I call the radius 1. That would make this side length 2 and that side length 2 because, hey, it's a square, all right? Because the diameter is twice the radius. So then I have, and then I'm interested in this area out here. So A1 is going to equal area of the square minus area of the semicircle. All right, and now we just have to work that bit. All right, so let's do that. Zoom in a little bit so I don't have to write so super huge. Area of the square is just 2 squared, and then area of the circle is pi r squared, but it's on 2 because it's a semicircle. All right, and so that gives us 4 minus, the r is 1, so r squared is 1, so that's 4 minus pi on 2 is our area 1. Okay, so that's the area of the red where point P makes an acute angle. Okay, if my point P lies outside that circle, then we are acute. If point P is in here, then we are obtuse. So now we need to calculate the probability. All right, so what I'm looking for probability, I'll just do this, boop, okay, add page, yeah. Okay, cool. All right, so if I want the probability that it's acute, that would be A1 divided by the total area of the square. The total area of the square. And so A1 is 4 minus pi on 2, and the total area of the square is 4. We can simplify that. 4 divided by 4 is 1, and then pi on 2 divided by 4 is pi on 8. And that's a nice way of expressing the answer. We could also have it be 8 minus pi on 8, which is just an arithmetic question. That's the same thing as that. Okay, so this is the probability. What does that work out to? Is a decimal? Oh, I'm glad you didn't ask, but I'm going to find it out. We're just going to do that. 8 minus pi is equal to this 4.8 number. Then we divide it by 8 is equal to about 61% chance. Okay, there's about a 61% chance that you get an acute angle. Now let's go back to Desmos, where I have my most beautiful visualization for us. And yeah, if I told you that that red area is 61% of the square, you probably wouldn't sneeze at me because it's clearly more than half. If I divide this square in half, all that side is, that's 50% of it. And none of it touches the circle. And then the bits around the circle add up to a little more than 10%. Cool. So that's actually a little surprising. I feel like I might have an error on my calculator there. What did I do? I did 8 minus pi divided by 8. Yeah, okay, all right, I believe it. All right, so that is the solution to that problem. Take a look at this week's problem of the week. We're going to start making these a nice rhythm, okay? I'm going to do problem of the week stuff Thursday or Friday each week. So we're going to start new problem and finish problem at the end of each week. All right, bye for now, everybody. Thanks so much for showing up for your math learning. And any questions, hit us up in the community. Bye for now.